The other form of the line that we're going to go over in this particular section is called slope-intercept form of a line, and this is probably no doubt not new to you. In slope-intercept form, we have two values given to us in the problem. We have this b, which is the y-intercept, and we have the m, which is the slope. So think back to a few slides ago. We need two things to graph a line. We need a point, which we have right here, and we need a slope, which we also have. Okay, so the two things we need to graph any line, a point and a slope, are given to us directly in this form, which makes it a very user-friendly form for graphing. Now, the only downside to slope-intercept form in regards to graphing, if there is a downside, is that sometimes the equations are not in slope-intercept form. You have to rewrite them yourself first. So let's do that. We want to get this in slope-intercept form, which means we need to write it as y equals mx plus b. Essentially, we need to solve for y, is the instruction here. I begin by subtracting 2x from both sides. So that gives me negative y equals negative 2x plus 9. Divide by negative 1. Make sure you get both terms here divided by the negative 1. So we get y equals 2x minus 9. Okay, so once we're in that slope-intercept form, very easy to graph, we're going to start here on the y-axis. So we're going to start at negative 9. And then here's our slope, 2. Now slope is typically written as a fraction, so 2 is the same as 2 over 1, which means we're going to go up 2 and right 1. And we can continue plotting out up to right 1. Fill up as much of the graph as you need so that you can draw a straight line. And there's our line drawn. Okay, one more example like this. Again, we need to do the hard part of solving this for y. I would begin though by subtracting x from both sides. So we get 3/4 y equals negative x plus 6. To get rid of the 3/4, we're going to multiply by the reciprocal 4/3. So over here also by 4/3, which means distributing 4/3. So we get y equals negative 4/3 x, and then 4/3 times 6 is 8. Okay, on our graph, the 8 tells us where to start on the y-axis. The negative 4/3 is our slope. I'm going to put the negative on the 4. Leave the 3 positive, so I'm going to go down 4, right 3. Down 4, right 3. I think one more time is enough. And there's our line. Alright, the last thing to go over in this particular section is two kind of special, unique cases of lines. They are the horizontal and the vertical line. Horizontal lines are always written as y equals, and they're just y equals a number. Y equals a constant is all. All we're going to do is go to that constant on the y-axis and then draw a horizontal. There's y equals 3. Okay. All horizontal lines have slopes of 0, as there is no vertical change. It'd be like a slope of 0 divided by something to just move horizontally. Now, vertical lines are always written as x equals a number. So we just go to that number on the x-axis, and then we draw a vertical line through it. Vertical lines, just of note, are not functions. It would certainly fail a vertical line test, as the vertical line hits everywhere on the line. It has a slope of undefined. It has a slope of undefined because its horizontal change is 0. And the horizontal change is represented in the denominator of the fraction, and we can't have the denominator of the fraction be 0. So anytime you see slope of undefined, that's talking about a vertical line. Slope of 0 is talking about horizontal line.